Welcome back to our Software Design and Development unit. In this lesson, we will look at unconditional loops, or fixed loops, as they are sometimes known. As always, we have our learning intentions. These are as follows. We will learn how instructions are repeated efficiently through the use of unconditional loops. We will learn how to total a series of numbers efficiently using an unconditional loop. And we will learn how to fill an array efficiently using an unconditional loop. Our success criteria is as follows. By the end of the lesson, we'll be able to describe the purpose of an unconditional loop and identify when it is appropriate to use one. We'll be able to implement the unconditional loop structure for. We'll be able to implement a running total using a loop, and be able to populate an array using a loop. As always, our success criteria and learning intentions should be referred to frequently throughout the lesson. This will allow you to gauge how well you have learned the content. When we program, it's often necessary to repeat the same instruction multiple times. Sometimes we can even repeat a set of instructions multiple times. This can be inefficient. This leads to the programmer repeating instructions after instruction. To help with this, developers and programmers will use iteration constructs. These are known as loops. In this example, we see a for loop. This is a type of unconditional loop. This type of loop will execute instructions a fixed number of times. In this example, 0 to 9, which will total 10 times. We use this type of loop when we know how many times we want instructions to be executed or repeated. These loops open with for and close with the word next. In this example, each iteration of the loop a new mark will be added to the variable total mark. This is known as a running total. We will now show an example of what we mean by this. Within our example code, the variable count will count how many times we have gone round the loop from 0 to 9. Every time we go round the loop, we will add a new mark to the current total. Again, this is referred to as a running total. Let's look at how this works. The first time round the loop, count will equal 0. We will add a new input, which will be 5. This will be added to the variable total mark. The next time round the loop, count will equal 1. Another input will be added, which is 7, and that will be added to the value already contained within total mark, which is 5. A new number, 12, will be assigned to total mark at this point. Third time round the loop, count will equal 2. Another input, this time 6, will be added to that total, 12. This new value 18 will then be reassigned to total mark. Fourth time round the loop, count is equal to 3, input 8, new value 26 assigned to total mark. Again, fifth time, input 4, we now have a running total of 30. Count equal 5, or the sixth time round the loop, input 9, we now have a running total of 39. Seventh time round the loop, count equals 6, input 7, we now have a new running total of 46. Each time we go round the loop, count increments by 1, a new input is added to the value already contained within total mark, and the result is then reassigned to total mark. In this case, 54. Count equal 8, the ninth time round, our input is 5, giving us a running total of 59, and our final time round the loop, our 10th time, our count will equal 9. Our final input would be 7. Again, this is added to the value already in total mark, which is 59, and the result of that is then reassigned to total mark, giving us 66. The loop will now end at this point. Loops can also be used to efficiently read and write data into arrays. This is called traversing an array. Instead of populating an array using a list of instructions as shown, we can use a loop, a fixed loop in this case, to populate that array. Notice that this cuts down the amount of instructions used. It makes our program far more efficient because there are less instructions to be executed. The counter from the unconditional loop is used as the index of the array. This determines which element we place our data. Again, let's look at our example. We have an array here called grades. It has 10 elements with index numbers, as we have previously seen when we spoke about arrays. Every time we go round our loop or iterate, our count will increment by 1. This variable is then used to indicate which element we will store our data, or which index. Let's work through this example. First time round, our count will be at 0. We will input the data A into grades 0. Next time round the loop, count changes to 1. This again determines the index that we will enter our input, which is B. This will be stored in grades 1. Second time, count is 2. Input is A. Our index is 2, and we insert our data. 3, 4, 5, 6, and each time we go round, our count increments by 1, and again we use this to determine the index or the element we are storing the data in. We are traversing through our array and inputting data. Final time round is 9, which means of course index 9 will be populated with our input B. Again, this count variable or counter variable is used within our expression to determine which index will be allocated our data. That brings us to the end of the lesson on unconditional loops or fixed loops. Hope you enjoyed the lesson. Hope you learned something about those fixed loops. There are plenty more lessons on software design and development. Don't forget to remind your friends about our channel, Grive High Business and Computing Science, and please don't forget to subscribe.